Everyone to our first ever product overview and demonstration. I'd like to start off by saying I'm incredibly proud for the opportunity to represent the engineers that are currently working with us and have previously, and the scientists that have all dedicated significant amounts of time, effort, and energy and passion into creating the products that I have the pleasure of demonstrating with you today. And they've done this over a number of decades, and like Jason said, the products and their capabilities are incredibly deep and have lots of breadth. So it's going to be difficult to get into each and every little corner, but hopefully by the end of today, you've got a taste for the strength and the usability of the platforms that we provide as part of our solutions. We utilize science, data, and our tremendous amounts of experience alongside technology to help industrial operators and communities carve a path forward together, fostering growth and prosperity for both. Not only do we provide solutions that address both those important constituents, but we focus on some of the world's most important sectors, from aviation, which supports the global economy, semiconductor manufacturing, which is in critical demand globally, through to the resources and minerals that power the world, past, present, and into our future needs. We support important water desalination projects where water is one of the most important resources around the world, through to water purification, waste and landfill management. The platforms that we provide our customers truly are required for them to operate in the rapidly evolving world around them. Today, I'm going to demonstrate products across each of our portfolios: EVS Aviation, EVS Water, and EVS Omnis, giving you a small insight into the products and the tools and how our customers interact with them on a day-to-day basis. It provides customers insight with science-led information that they can depend on to make critical, valuable, and long-term business decisions. I think it's important to note that our systems go far beyond compliance requirements of a site. Yes, it's true that once they're running, they're often bound by operational and licenses to continue to operate, but the solutions really hit the stride with the customers and our stakeholders when they look at how to operate with less wastage and higher profitability and strong ties to the community within those known and emerging constraints, which is exactly where we like to start the conversation with our customers. The platforms come front and center to the daily operation and fabric of our customers' operating plans and community engagement tools. All right, the next one we're going to touch on is our EVS Water portfolio. Largely, the EVS Water portfolio is focused on utilization of digital twins of our customers' facilities, combined with scientifically based deterministic modeling and machine learning capabilities to utilize the easiest sets of inputs available to derive the most advanced sets of output, helping them perform more effectively and reduce their risk. There are three main products in the EVS Water portfolio. We have SUEX, which I'm going to discuss in a little bit more depth and to do a demo of. And there's Plant Designer and Plant Optimizer. Plant Designer is a planning design tool, of which Optimizer is the bigger brother, and which I'll discuss shortly. Today we'll be demoing SUEX, and we'll leave Plant Optimizer for another day when we have a little bit more time on our side to do a demo of. Plant Optimizer is a very unique and comprehensive tool for our customers who are very much based in using traditional-based methods to understand how they can optimize their operations. They are constantly juggling with power bills, chemical dosing choices to achieve either drinking water requirements for an area or industrial return of water to local communities. Traditionally, this has been via what we've always done for the last 5 to 10 years, which both has a lot of risk and can incorporate lots of run-on costs. So what we do is we create a digital twin of their facility. We use deterministic modeling using 70 different scientific processes and layer that machine learning on top of it, and essentially provide them hour-by-hour set points for the next 24 hours of operation, which tells them how much temperature to use at a certain area, how much chemical to dispense at a certain area. In some of our most recent site examples, upon the initial recommendations derived over 20% reduction in their chemical usage. In just one email, it said, this is what you did yesterday, this is what you can do tomorrow, and we show them a 20% benefit in those things. So it's an incredibly powerful platform for them to gain access to. And that works for both water purification and desalination facilities, through to light and heavy industries and food and beverage type industries as well, all struggle with the same constraints and are looking for the same answers. Swapping over to SUEX. SUEX is an incredibly powerful platform that gives sewer operators never before access to timely and in-depth insights as to how their network is actually operating. It's only ever been previously achievable through manual labor and high volumes of testing and validation, which actually just hasn't been possible on a regular basis, and it's not really helpful for understanding all of the different parameters across your entire network. What SUEX does is it takes a modest set of measures and inputs and uses machine learning to derive an accurate simulation of that network. Immediately, that simulation provides detailed cross-network data of the system, where the raw biomass might exist, where the buildup of methane gas is going to be, where hydrogen sulfide is. And all of those different scientific and chemical-based parameters play a really significant part in their operations, whether it be the increasing demand for them to understand what their impact on climate change is with methane emissions, through to safety with hydrogen sulfide, and one that we've likely all experienced with the smell, the unpleasant smell of methane, of hydrogen sulfide being emitted in your neighborhood. Not being across these things means that the community experiences the odors. You have to then respond with a very short time frame and not much information. We give you that information, not just today, but an ability to predict it going forward. The magic of SUEX is actually when customers start to ideate and test potential improvements to the networks themselves. Investing in a new chemical dosing station or ventilation program can be a capital works program in the tens of millions of dollars. Not something you want to do overnight because you've had a reported or unexpected issue, but something you want to plan. You want to plan very effectively. So SUEX, we're using SUEX, the customers can independently build and test these changes to their networks, not in days, not in months or weeks, but in hours, which used to be a task that was led up to potential consultant engagements that they had done 1, 2, or 3 years previously that they continue to rehash. This puts the tools in their hands and demonstrably makes a marked improvement on their processes and their ability to plan into the future. So we're helping them with climate change, with their safety, their odor, and the corrosion. The system that goes behind SUEX, again, I stress that it takes in a modest number of inputs, which means our customers can get up and going really quickly. We take in their hydraulic model that shows where their sewer pipes are going, how large they are, and a number of sporadic samples through their site, which are generally very easily collected or already known. With that, we build that into the model, and even soon releases of SUEX will allow them to build the model themselves. And they'll be able to then run our model process on as many different iterations of their potential systems that they want. And that will tell them where they have hydrogen sulfide buildups, where corrosion is happening quickly. And if they do such capital investments, that this will be the derived benefit for them. So they'll get more accurate representation of that risk in their capital allocation and more efficient and effective responses to their complaints.
Just on that, so when you talk about those inputs, I think it's important to state that that is data-driven inputs that we're taking from the customer.
They're data-driven inputs. Typically, they're difficult to get across your network. Some of these samples you need to collect en masse when you're doing a manual approach, and put the samples on ice and take them back to the laboratory and get information from. Not something you want to be doing every week. You can put 1 or 2 of those samples throughout your network in SUEX, and we will work out the rest. So we're really giving them a solution that is not otherwise feasible or achievable to do. Now, jumping into the SUEX product, Aquaroma is another demo site that we have running in our production environment. And what you see here is the customer's sewer network, which outlines all of their pipes. It has their sizes, it has their flow rates in them, which they all typically have on hand and provide into this and upload it to the system. We then have all of the different manholes throughout the facility, gravity mains, wastewater treatment plants, pumping stations are all built into this network. What you then do is they create a scenario, and we essentially have a vanilla scenario here which has calculated throughout their entire network all of these different parameters. So without measuring or sending people to site on a daily basis, we've simulated what the likely minimum, maximum, and mean biomass, which is the raw sewage, is at this point in time across their entire network. And what you can do, it's not just single time, it's time phased. As humans, we have diurnal cycles, which means there are different behaviors through a sewer network, morning, day, and night. And they significantly influence what those min maxes are and what your response may be. So we model these throughout the entire data set, which is often 24 hours. It's not in this particular demo case, but it will traditionally show a 24-hour area. So this is raw biomass simulated throughout the entire facility. The next thing we can look at is hydrogen sulfide gas. So again, without measuring physically in situ, we've been able to calculate with their input files where and to what level of concentration there's hydrogen sulfide gas. This is measurable in traditional setups, but hydrogen sulfide meters don't stand up very well to the incredibly harsh environment that is a sewer network. They're inexpensive, or they're expensive, and they're hard to maintain. So the ability to simulate all of these things is incredibly powerful. The things that influence the level of hydrogen sulfide are factors such as flow time and speed, anaerobic, how much air is present in the system at the time, if there's a rising main nearby to increase the flow, and the concentration of dissolved oxygen. If there's none of that available, bacteria use the sulfur and generate hydrogen sulfide. And what the SEWEX model is doing is running all of those models and predicting them into the future so you can work off a real simulation of what your system's potentially going to look like. Now, if we're looking at a potential hydrogen sulfide issue in this node on the system, you may want to do something about it in the future planning cycle. However, when you attend site, one of the other things that operators are very conscious of is the amount of methane gas. Traditionally a safety issue, and if you arrive and the issue is much more significant than you planned, it poses a health issue or safety issue to your workers and can often stop and have works replanned. However, as one of the other models that we run through the system, we also predict methane gas amounts. So I can flick the system over and you can see the maximum methane gas concentrations across the network. Generally, anything over 5% to 17% is known as dangerous, if not explosive. So what we can see is in the area of work that we would potentially be initiating, there is a higher level, but it's not nearly 1%, so we can probably initiate that work. So this information is helpful not just for the operations team who may need to be responding to it, but what we've seen is once the sewage operators get a hold of this, other departments start to hear about the types of information that they can glean from the simulation, and they want to start getting involved in the system so they can start making their decisions. So it's really powerful that way. The other exceptional power to this is not just simulating what your system looks like today, but it's simulating what could potentially happen and what the benefits and changes to your system are if you make changes to it. So one of the key changes that a sewage operator could make is they could add a dosing station, which is a fixed facility that essentially deploys chemicals into the sewer network that either increases the amount of oxygen, so that's ventilation, or helps the chemical breakdown increase flow and improve the network parameters. Now, considering the number of inputs required to make that determination as to its impact, there's actually quite a lot of computation that goes on. And that's where SEWEX comes in, because you can, as an independent operator of these things, without external help, including ours, you can say, I want to run a new scenario with a new testing concept of a dosing station. So what you can do, I'm just going to turn off the skipped nodes that we don't use, and say in this gravity main, I'm going to add a doser, a theoretical doser. So we'll call this GM23 dosing concept. And it will dose at 75 milligrams per liter, and the doser will be active. So I'll add that to the system. And I can then say scenario, add scenario, I can input all of the different potential data inputs that I have, whether I have new water quality parameters or new velocity or flow information. And if I don't, that's okay. I have my GM23 dosing concept, and I've also got a trial 3407 dosing station, which is actually outputting more 100 milligrams. I can then create that scenario, and it will derive an entirely different simulation demonstrating those downstream impacts of it. So again, a really powerful tool once you get all the different departments that are interested in augmenting the network to achieve their different departmental goals.
So just to re-emphasize this point, so this is totally unique software. This is, you know, a strong IP that we now have. How would our customers go through this process previously?
So previously, what they would have to do is predetermine years potentially in advance all of the different options that they want to run. It then gets taken to an expert, generally in a consulting capacity, who would use historically the SUEX model in a once-off derivative with each of those different simulations in it, taking into account no changes over that period of time. It'll give you a printout or an Excel sheet to say, here are all the different changes. And what we see is that customers will refer to that, not just when they receive that study, but for 1 year, 2 years, 3 years, and make their capital planning decisions based off of that. This way, they can self-serve all of that information, ideation themselves, and come up with a really effective capital planning tool. I like to see that this is one of the best examples, I think, of democratizing some of the world's best science. We're taking what used to be a very difficult to use and utilize piece of technology and building a really significant wrapper around it so they can take advantage of it. Thanks. All right, so that is us and SUEX completed.
So last one now is aviation.
Now is aviation.